the wearables is actually interesting. I mean, they could be used for everything from what they call a neural bypass. So in other words, you could pick up nerve impulses from one area, and it could be any number of areas in the body. There's some great videos too where they pick up nerve impulses from one part of the body or even the brain and transmit it to another part of the body. That has a lot of applications for people who've had nerve injuries. Mm-hmm. There's force sensors, movement sensors, chemistry sensors. There's all kinds of applications in wearables for printed electronics. And a lot of the inks for the wearables, if you use the right substrate, the right fabric, and the right encapsulant, withstand anywhere from 20 to 100 washings, and they're still fully functional. So and again, as the material science gets better, that'll get extended even further. Mm-hmm. But just going back to the inks, just for example, some of the higher silver loading inks, some of the better inks are 5 milliohms per square per mil of thickness, and some of them, let's just say, in staying with the silver inks, they might be 150 milliohms per square. Of course, the carbon inks may be 20 ohms per square, but you want that resistivity in that case. So there, again, there are many different inks for different applications, and this is what your customers would need to know, or designers would need to know to design some of the circuitry, depending on their application. I just have another sample here. This is a printed antenna. In fact, some of the antennas, the TV antennas that you could stick in your window, mm-hmm. To get local broadcast, it uses printed electronics, silver inks.
Interesting.
So a lot of different applications, and you could put them anywhere, and you could put them on materials that you couldn't use in a traditional PCB process.